Start product of vector by scalar. If A be any given vector and lambda is any scalar, then B is a vector defined as like this. Here B is also a vector quantity where lambda is scalar, whereas this is a vector A is a vector quantity. This is actually product of a scalar by a vector. Here the modulus of vector B is mod of B, and it's depend on both modulus of lambda, scalar quantity, and also on B. If lambda is dimensionless, then vector B has same dimension as vector A. That is, if A is a velocity vector, then B is also a velocity vector if lambda is dimensionless. This is if lambda has dimension, so many dimension, then vector B has different dimension as that of vector A. Suppose lambda has a dimension, this lambda has a dimension of mass and A is a dimension of velocity, then this has a dimension of linear momentum. That is, B has the linear momentum when lambda has dimension of mass and vector A has dimension of velocity. So clearly vector B and A has different dimension if lambda has any dimension. Now if lambda is positive, then vector B is in the same sense as the vector A. That is, if vector A is pointing in this direction, B is also in this direction. Like this. A in this sense, B is also in this. If lambda is negative, then A and B vector are in opposite sense, like this. Here lambda is negative, then A is in this direction, then B is in opposite. Suppose lambda is equal to -1, then vector A and vector B are pointing in opposite direction but in equal in magnitude. So we draw vector A, this is vector A and this is vector A, has arrow length equal but opposite in direction because lambda, here is the lambda A is negative, -1. If lambda equal to +1, then B is pointing in the same sense and of equal magnitude.